Section 6.2, example 10, integrating power series. So for each of the following functions f, find a power series representation for f by integrating the power series for f prime and find its interval of convergence. Ooh, okay, so what they didn't mention this as leaving our functions as the derivatives or integrals. So what I feel like we're going to end up doing is taking the derivative, and then once we have the derivative, automatically taking the integral of it. All right, let's give it a try. So for each of the following, let's take the derivative first of f of x. So f prime of x is equal to the derivative of ln of 1 plus x is 1 over 1 plus x. Oh, I see it. So this ends up being 1 over 1 minus negative x. All right, so for this, we actually have something that we could work with, right? So f prime of x is equal to, we could turn this into a power series and say that this is the sum as n goes from 0 to infinity of our first term is 1, negative x is our ratio, and we're raising that to the power n. All right, so let's expand it, because here I don't want to just come up with these little values. So like the integral of this would be 1 over n, but let's just make sure f prime of x. Let's look at this infinite sum. So as we plug 0 in for n, there we go. As we plug 0 in for n, the first term is 1. When we plug 1 in for n, we get a negative x. When we plug 2 in for n, we get a positive x squared minus x cubed plus x4 minus x5. I don't think we need the rest of those. But now that we do that, our original question was f of x, not f prime of x. So let's take the integral. So this is going to be f of x. And now the integral of 1 is going to be x minus the integral of x is going to be 1 over 2x squared. Plus the integral of x squared is going to be 1 over 3x cubed minus 1 over 4x4 plus 1 over 5x5 plus infinity. And at this point, I feel like we could come up with a sum. So we could say that f of x is equal to the sum as n goes from 0 to infinity. It looks like each of these values, we could say that this is 1 over 1. Each of these denominators matches the exponent. So we could say 1 over n here for the coefficient. X to the power n, does that match? So x to the power n, 0. Oh, I don't like that. So why don't we do n plus 1 instead? So 1 over n plus 1, x to the power of n plus 1. All right, so it should start off with x. So 0, we have a coefficient of 1. 0, we have an exponent of 1. So now for the second term, oh, we need that negative as well. So negative 1 to the power n. That tells us that all odd numbers are going to be negative. So no, we're going to do n minus 1. Or we could do n plus 1. There's pluses all over the place. All right, so when we plug 0 in, actually, it should just be n. All right, so for the first term, plugging 0 in here, we end up with 1. We end up with 1. We end up with positive. All right, there we go. So this is our infinite sum for this sequence here. And I think that's pretty cool. But we've also determined that I'm not normal. All right, now same thing here. We're going to take the derivative, and once we do that, we take the integral. So let's take the derivative. F prime of x is equal to, this is one of the trig series, so 1 plus x squared is what it matches to. 1 over 1 plus x squared. And in order to turn this into a power series, we need to have a minus there in the middle. So 1 minus negative x squared. Oh, there was one thing I forgot with this previous part. Our interval of convergence. So interval of convergence is going to come from, let me see. If we make it, so let's, instead of just doing this, we do one more. So as n goes from 1 to infinity, let's do that. So we'll go 1 over n, x to the power n, and then we have negative 1, n plus 1. Yes, so that way, since this is x to the power n, we are able to see our interval of convergence and say that absolute value of x less than 1. So x goes from negative 1 up to 1. And there we go there. All right, we have that. Now let's take a look at this one. Okay, so f prime of x, 1 over 1 minus x squared. We're able to rewrite this like this. So that way we could say that f prime of x is this power series. The sum, as n goes from 0 to infinity, of negative x squared to the power n, which ends up being 0 is 1, plus when n is 1, we have a negative x squared, plus x to the power 4 minus x to the power 6, plus x to the power 8, plus dot, dot, dot. And that's f prime of x. Let's take the integral of this and see what we end up getting. So the integral of 1 is going to be x minus 1 over 3 x cubed plus 1 over 5 x5 minus 1 over 7 x7 plus 1 over 9 x9. And I'm pretty sure that's enough to show some sort of relation. So we'll say n goes from 0 to infinity of coefficients are all odd numbers. So I'm going to say 2n plus 1. So 1 over 2n plus 1. So for the first one, we have 1. For the second one, 2, 3. Okay, I like that. And then we have x to the power n. No, x to the power 2n plus 1. Yes, because the denominator of the coefficient is equivalent to the exponent. So that matches. And now since we're alternating, we go negative 1 to the power of n plus 1. So 0 is positive, no, it would just be n. And now that we have that, I don't like that we can't put this to the power of n. So let's switch it up a little bit just so that it's to the power of n so we can find our interval of convergence. So n goes from 1 to infinity. We'll say 1 over 2n minus 1 So that way our first value ends up being 1. This goes to x to the, actually, it's not going to help us at all. We could leave it as is. We'll just take our interval of convergence to come from the absolute value of negative, because we have this negative over here too, negative x squared less than 1. All right, so that means that our interval of convergence goes from -1 up to 1. But let's see, do we have, yeah, so let's look at each of the endpoints. So when x is 1, what do we have? So when x is -1 in our function, over here, so when x is -1, hold on. In our function over here, so when x is -1, because we're looking at interval of convergence here, x is -1, because of that, it ends up being positive, so we're actually converging at that point. And also when x is equal to +1, we're also converging at that point too. And there we go. So this is our infinite sum and our interval of convergence. If you have any questions, please feel free to ask. Otherwise, bye.